Hello everybody, in this video I would like to go over function notation, how to use it, and what we're going to do with it in terms of just evaluating using function notation. So function notation is just another way to write y equals when we're dealing with a function. So hopefully before this video you've seen a video on what is a function and what are relations and what are functions. And so all we're doing here is we're going to rewrite a y equals 2x plus 1 as f of x equals 2x plus 1. So again, this is f of x. Okay, this is our function of x, which is just another way of saying y. So if we plug in a value for x, we're basically, we're going to plug in a value over here, and then whatever value we get, that's going to be our y value if we're going to graph it. So we'll take a look at a graph in just a second so you can get an idea of what we're talking about. So let's take a look at some examples. Let's suppose we're given a function like 3 minus x cubed, and we want to find f of negative 2. So this negative 2, we're going to plug in where we see an x. Alright, so f of negative 2 is 3 times negative 2 cubed, and we're going to want to put that in parentheses. So we're just going to evaluate that. 3 minus negative 2 cubed is negative 8. So 3 minus a minus 8, so we're going to change it to plus. So 3 plus 8 is 11. So what I'm saying is, if I was going to graph this, I would be looking at the point x equals negative 2 and y equals 11. Okay, so this would be my point. This would be the point on my x and y axis. Sometimes you'll see something like this on an x. You'll see on a graph. You'll see a comma f of a, and that just means this is x and this is y. Okay, this is the x value and this is y when you plug in the x into your function. Okay, so let's take a look at some more here. Now we have this function here. So we're going to plug in negative 1 where we see an x. Okay, so in both spots here. So we're going to have h of negative 1 is equal to 3 times negative 1 squared minus 3 times negative 1 minus 27. So 1 squared is just positive 1. 3 times negative 1, so positive 3 minus 27. So 3 plus 3 is 6, minus 27 is negative 21. Okay, that's your answer. So again, if we were to graph this, we would have negative 1 comma negative 21 as our point. Okay, why don't you practice this one and then come back and pause it and come back and see the solution. So we're going to plug in 4. And we're going to get 2 times 16 minus 3 times 4, which is 12. 2 times 16 is 32. Minus 12 is 20. Alright, and that's it. Okay, plug in again here. Practice this one. I'm going to plug in negative 3 in for... Oh, that's not straight. That way. Okay. That's my, brake sound. It's not the greatest brake sound, but hey. You can only do so much when we're talking about, video and math, right? 6 times 3 is 18. And then, what I'm going to do? I'm going to square this first, so that's going to be 9. So I'm going to have negative 18 minus 18, which is negative 36. Yes, negative 36. Okay, that's it. All right, let's take a look at one more thing here. So I've got a graph. And this graph, this is going to be my graph of y equals f of x. Okay? So what I'd like to do here is maybe let's see what is f of 0? What is f of 0? Well, remember, this stands for what is the y value? What is our y value when x is equal to 0? So x is equal to 0 right here, and my y value is also 0, because this is the point 0 comma 0. So my y value is 0. Let's look at another one. what is f of 2? So again, this is what is the y value, what is my y value when x is 2? So x is 2 right here. There's 2 for x. So I'm going to go down to where my function is on x equals 2. Oh, it's right there. Right there. So my y value is -4. So this is -4. Remember, this is the point 2 comma -4. This is point 2 comma -4. So why don't you do this? Why don't you do this? Why don't you find what is f of -2? So if you looked at that, -2, here's the x, and I go down to my y where it crosses the function. It's right there, which is -4 again. So this is also -4. Okay? So this is how we would look at points and look at our function notation graphically in some sort of graph. Okay? All right, that's it, guys, for my short little video on function notation.